You're on the Bamboo Agroforestry farm, and it's been a wet winter this year and leading into a wet spring, and as a result soil erosion has come to the fore again. The biggest problem we have on this farm is tunnel erosion, where the subsurface clay soils wash out, leading to a tunnel running down the gullies, and as a result, when that tunnel gets very large underneath the quite stable surface soil, the surface soil collapses and you end up with these large holes. Now this is a problem resulting from sodic soils. Sodic soils cover 30% of the Australian agricultural landscape, particularly on the east coast, from Tasmania right up to North Queensland. And what we're talking about here is where you've got clay soils, clay subsoils that are very high in sodium. And that reduces their ability to stay stable when wet. So let's just take some of that clay subsoil from down here, which is quite dry and hard, and we'll just drop it in water, and you'll see how quickly it starts to disperse. And as a result of that, every time this soil gets wet and saturated, eventually it starts running, whether it's the banks of the creek systems or through tunnels underneath the surface soil, and it runs down into the water and turns the creeks brown. Of course, water, excess water, is part of the problem, but there's also a chemical issue here. So you can see now that the clay is fully in suspension, and wherever the water goes now, so does the clay. If we take some of this solution and we put it in a jar, we have to take 2 jars so I can show you the issue. So we've got the same solution in 2 different jars. We're going to put some calcium sulfate, gypsum, into one, and we'll stir it up. So we're going to leave those there now, and I want to show you what actually happens. Okay, we've come back and we're comparing the 2 jars. This is the one that I added the gypsum into, and you can see that it's almost clear. There's been a lot of sedimentation down to the bottom, and that's because the calcium ions in the gypsum have replaced the sodium ions, forming a stronger bond with the negative charged clay particles, allowing them to settle out. You can see our original jar, like our dams and the ponds, remains cloudy because those sodium ions encourage the dispersion and hold that clay in suspension. So in this gully we planted trees. We planted eucalypts and blackwoods to try and control the erosion. But we found that those native species can't get their roots down into this toxic sodic clay. So they can't dry it out, but more importantly, they can't go into that clay, add organic matter, and change the chemistry of it. We've planted about 70 different species for timber and conservation and aesthetics across our farm. We manage them in all different ways. And I found only one species will actually grow and change the soil chemistry on this site. Let's go and have a look at that tree. So I'm digging down underneath these trees that have been here for 33 years, right down into the same clay that we looked at over there. And the first thing, I can feel it's clay. It's sticky and hard, but it's black. And it's black because those fine roots have been working their way into it, growing and dying every year. So here's a tree that can grow into that horrible sodic clay. And I think in doing so, it changes the chemistry of it. So let's put some of it into water, shake it up, and the clump is still there. It doesn't disperse like the sodic clay in the other valley there underneath the eucalypts. So what's going on here? These are Coast Redwoods. Redwoods have the ability to grow into that heavy clay, and in doing so they do 2 things. They leave organic matter behind when they die, but they also, as they grow, they release hydrogen ions. Now hydrogen ions can play a critical role in breaking down calcite, which is in all clays but is inert in most cases. If you can break down the calcite, release the calcium inherently held in that clay soil into an iron form, that calcium can bind with the clay. We've had very large rainfall events here. I've photographed torrents of water coming down from that gully we were in just next to here before, with yellow clay washing out the bottom. Here, the water just washed across the top of the soil because there was no way that it could travel through the underground network because of those roots. There were no tunnels underneath the redwoods. So if we're going to look at solving land degradation problems, if we understand the science, we can then find and understand what the trees have to do to solve the problem. And it may be, as in this case, involve planting exotic species, such as redwood, which you can see we're also growing for timber production. And when we harvest, these root systems stay alive and regrow. So we're actually solving the soil erosion problem whilst growing trees for a profit. And that's the key in a lot of the work that we're doing on this farm, finding ways that we can grow trees for profit that also support and enhance conservation values, whether it's soil, biodiversity, animal welfare, or aesthetics. Thanks very much.